He was born in the county of Kent, started in England, started bird watching in 1972 at the age of 8, mostly at the Beddington sewage pond, is that right, dude? In London. His grandmother bought Dave a peanut mesh feeder, and he saw green finches and a European finch. And from that point on, he was hooked on bird. Dave has worked as director of bird conservation for Audubon, Maryland since 2004, leading efforts to protect, manage, and monitor bird habitats across Maryland. He now leads Audubon's coastal program in Maryland. He completed his PhD in wildlife ecology at the University of Wisconsin-Madison, where his research focused on the ecology and behavior of the brown-headed cowbird. He also taught ecology at Johns Hopkins University from 2003 to 2023. So Dave has come all the way from Baltimore, deserves a hand just for that. He said when he hit our beltway, the word was it was a little intense. Is that right, Dave? Yeah. All right. So please welcome David Curson to tell us about Marshes for tomorrow.
Yeah, thank you very much for that welcome. It's great to be back here. I think it was a few years ago that I last came and gave a talk. It was probably about important bird areas back then. But in the last decade or so, we've really come to focus on our salt marsh conservation work. It's now a big part of what we do in Maryland. And as Mike said, I've been working with Audubon for 22 years now, and I'm delighted to be here. So let's here we go. So let me just introduce you to salt marshes. Maryland has some really big salt marshes. These are basically grasslands that they are in tidal coastal areas. So from an ecological perspective, they're very interesting in that it's a very harsh environment and very few plants to actually grow there successfully. Just a handful of species dominate a big area of marsh like this. Most of it's grassland, and so from a bird perspective, what you're really looking at here is a prairie habitat that's intertidal. So a tidal prairie. And it's, before I get into talking about the birds of salt marshes, let's look at, here we go. One thing that's really important to talk about with marshes is what's so special about them. Why do we need them? So from a conservation standpoint, they're actually really important. Here in Maryland, we have some of the largest salt marshes in the northeastern United States. We have about 170,000 acres of them. And they're important not just for birds, but they provide a bunch of ecosystem services that are really important. Firstly, the little tidal guts and creeks in the marsh are nursery areas for fish, commercially important species of fish, and I believe about 2/3 of the species of fish that we harvest and eat in the Chesapeake Bay rely on salt marsh creeks in the fry stage. The marshes also form a really important physical buffer against storms and storm surge that protect coastal communities like Crisfield and other towns around Chesapeake Bay from the full effects of big storm surges. They also bring in a lot of dollars from tourists. They're very popular places for tourists to go to. And for local people, they're really important for recreational fishing, recreational crabbing, biking, and a lot of other things. So they're important places. And we found by talking to people in communities on the lower eastern shore just how much people love their salt marshes down there. Another really important value is that they're a filter for nutrient pollutants. One of the big goals of the Chesapeake Bay program is to reduce the amount of phosphates and nitrates in the water of Chesapeake Bay. And the plant life in the marshes actually acts like a filter and soaks up these nutrients and reduces the nutrient loading in Chesapeake Bay waters. And in a similar way, the plant material underneath the living plants, the kind of the decomposed peat, is a huge carbon store. Some of these marshes have been growing here for thousands of years, and at Blackwater Wildlife Refuge, there are places where there's 50 feet of peat underneath the marsh before you hit the bedrock. And so keeping that carbon locked safely away, rather than allowing it to become mobilized into the water column, is actually very important when it comes to fighting climate change. So there are many reasons why we want to preserve our salt marshes. And then lastly, of course, talking to a bunch of birders, we've got our biodiversity. And one of the really distinctive things about salt marshes is that there are just a handful of species in the world, of vertebrate species, that are entirely endemic to salt marshes. And two of them are birds, and they both live in Maryland. So let's take a look at these. Species number one, here is the seaside sparrow, very distinctive bird. I mean, it's grey, the yellow bit by its beak, but for those of us who love marshes, it's a very distinctive bird. They're actually really common in the marshes. If you go down to Irish Grove, the sanctuary owned by MOS down in Somerset County, or Blackwater Wildlife Refuge, you can see a lot of these salt marsh sparrows, and you see them quite close up as well. Beautiful birds in the same genus as the grasshopper sparrow, Henslow sparrows, again, birds of the prairie. And so these birds that only live in our East Coast salt marshes, basically they evolved there by one ancestral Amadramus sparrow, basically set up home in the marshes and then became increasingly isolated from other species and became its own species, the seaside sparrow. Now, this kind of evolutionary process happened not just once but twice. With, well, not with this black whale, but with the bird I'll show you after. So I'll talk about black whales now. So black whale, a very enigmatic bird. The eastern black whale is almost confined to salt marshes. It does actually have, the species as a whole has a wide distribution across the Western Hemisphere, but in little pockets of wetlands with very, very shallow water. So a distinctive bird with a very distinctive call. And this used to be reasonably common in parts of Maryland salt marshes, especially along the Elliott Island Road in Dorchester County, but they have become extremely rare. They're now federally listed as federally threatened. And there's only one or two pairs left in Maryland. So they're extremely rare now, and they're rare along the entire East Coast. So this bird is almost confined to salt marshes, a very special bird. Now here's our conservation star, and this is the salt marsh sparrow, very closely related to the seaside sparrow, a little bit more colourful with those beautiful orange stripes on the head. This bird it has a narrower ecological niche than the seaside sparrow. They only live in certain kinds of salt marsh. The kinds of salt marsh which is dominated by grass meadow. So the basically salt hay grass and salt grass meadows where the grass doesn't quite come up to your knee. This is where the salt marsh sparrows like to live. They put their nests under a tussock of grass, and their nests are right on the ground, so they're really vulnerable to flooding. So this means that with sea level rise, they are quite imperiled. Now this bird has a very small range. They only nest in the high zone salt marshes from Maine down to Virginia. And here in Maryland, we actually have a quarter of the world's population nesting in Maryland. So we have a big responsibility for them. Range-wide, they're declining around 9% a year because the sea level rise and nest flooding, they get very few young off the nest successfully in our populations of them. And it's a candidate species for listing under the ESA, but there's a great concern that this species could be extinct by 2060 if current trends continue. Okay, so what's happening with our Maryland salt marshes? Well, this is a drone image of salt marsh in the Maryland coastal bays. Now, the Maryland coastal bays were very extensively grid ditched, which means that their elevation dropped as a result of that grid ditching and drying halfway through the last century. And in the last 15 years, in a lot of the coastal bays marshes, they have become increasingly ponded. So this marsh at Public Landing, if you visited it around 2010, it was mostly marsh. And then this photo was taken, I think, about 2 or 3 years ago, and now it's mostly pond. So we're seeing a lot of loss of salt marsh already due to sea level rise in Maryland, but it's interesting, most of the loss is not due to shoreline erosion, but actually due to interior ponding. So the excessive flooding that you get on the surface of the marsh actually rots out the vegetation, and it causes the soil, your biochemical changes in the soil, slurry it up, it collapses, the soil washes out, and it leaves these ponds. And this is happening not just in the coastal bays, but in the large areas of Dorchester County as well, and some areas of Somerset County. So this is a huge problem. We may well lose the great majority of our salt marshes in Maryland, of our current salt marshes this century. So it's a great concern. Now, just kind of a nice human, or an interesting human dimension of marsh loss is Holland Island. Holland Island is an island in the middle of the Chesapeake Bay. And about 180 years ago, there was a community of about 360 people living there with a school, post office, all the trappings of a small village. And today, there's no one living there. And I took this photo in 2010. That's the last house on Holland Island. And the owner would still go out there and try and shore up his house. Now, this, I took this in July 2010. You can see there's pelicans there. There's a pelican colony on the island. And in October that year, just 3 or 4 months after I took the photo, the gale blew that house down. So then there were no houses up on the island. So 13 islands in the Chesapeake Bay have been lost to erosion in the last 200 years. Okay. So why is Maryland so vulnerable to sea level rise? You've all heard, I imagine, about sea level rise being driven by increasing carbon dioxide in the atmosphere and global warming. But Maryland kind of has it bad because our relative rate of sea level rise is twice the global average, and that's because we have regional land subsidence. Back in the Ice Age, 13,000+ years ago, the weight of ice on Canada pushed Canada down, and the other end of the tectonic plate is the mid-Atlantic, and that bulged up. So when the ice disappeared at the end of the Ice Age, Canada kind of elapsed, and now the land is sinking. So it's kind of a counterbalance thing, about 1.5 millimeters a year. So that is a big knock against our marshes and sea level rise. But we also, in the Chesapeake Bay, we have a very narrow tidal range, only 2.5 feet between low tide and high tide. And that means that our marshes can form on this very narrow level. So they're very, very flat. And that means that large areas of marsh can disappear at once, okay, because they all get flooded at the same time. Now, the Maryland Commission for Climate Change predicts that we'll have about 3 feet sea level rise by 2100. And it doesn't take a rocket scientist to realize that if your marshes kind of form in under a 2.5 foot tidal range, that they're really threatened. They'll probably lose most of today's marshes by 2100. So Audubon really adopted this as a big concern and a big kind of flagship conservation program here in the Mid-Atlantic because of this unique assemblage of birds that we have in the marshes. Now, there are some things you can do to save and restore disappearing salt marsh. And these two photos are going to illustrate two categories. So on the left, we've got what you can do if your marsh is still high enough to drain into tidal creeks. Where you have ponding, you can actually dig a little tiny channel, which we call a funnel, just about 12 inches wide, and release the water from the surface of the marsh. This only works if it's, fairly high marsh. And it's like a low-cost, low-tech method of marsh restoration. You can actually dig these with a shovel, so you don't need big machines, or you can use excavator machines. And the cost is something about 4,000 an acre, including all the design and everything else. There have been a few of these one-off projects done in the Maryland coastal bays in the last 2 or 3 years. Now, if your marsh is already too low, you want to raise it back to, or restore it to high marsh suitable for the salt marsh sparrow and other birds, you're going to need to add sediment. And this is a photo of a project done by Fish and Wildlife Service, Audubon, and the Conservation Fund at Blackwater back in 2016, where we dredged sediment from the Blackwater River, sprayed it onto 35 acres of marsh, and actually raised the elevation about 4 to 6 inches. We probably added 2 or 3 decades of life to that area of marsh. But this is a lot more expensive. You can see the cost estimates here, very wide range, but anywhere from $50,000 to near almost $200,000 an acre is a lot of money. So gives some people pause. So a couple of years ago, Fish and Wildlife Service approached Audubon and said, can you lead an effort to come up with a landscape scale conservation plan for Maryland salt marshes, specifically aimed at the salt marsh sparrow? We'd love to help this species, then perhaps we won't need to list it. So luckily, at that time, there was already a conservation plan that had just been written by the Atlantic Coast Joint Venture, which is a coalition conservation organizations focused on birds. And that plan had identified, Mary, you see the red line here on the table, that the amount of habitat needed to keep 6,300 salt marsh sparrows in Maryland was just short of 25,000 acres. So we adopted that acreage as our target in our landscape scale conservation plan, which we called Marshes for Tomorrow. So Fish and Wildlife Service provided the funding. We got another supplementary grant from National Fish and Wildlife Foundation. And with Marshes for Tomorrow, we had 3 objectives. Firstly, we wanted to find the best and the most suitable 25,000 acres plus of salt marshes that we could keep long-term for salt marsh sparrows. Secondly, we wanted to actually decide or say what kind of restoration is needed in those areas, which areas need restoration, and then what type of restoration do they need. And thirdly, we wanted to involve local communities in this decision-making process to increase kind of people's buy-in for marsh restoration and have somewhat the board approval of these local communities. Now, we organized a project as part of the Delmarva Restoration and Conservation Network, which is a wide alliance of non-profits and government agencies on the Eastern Shore. Okay. And these green areas show the areas that we started with, about 67,000 acres of marsh where we thought that the salt marsh sparrows, and we thought, well, let's try to find out 25,000 acres from these areas, which are known to be marshes where salt marsh sparrows are. So How do we identify our 25,000 acres? We had to come up with a way of narrowing down the 67,000 acres to this manageable target. By the way, this photo is at Irish Grove Sanctuary down in Somerset County. Beautiful salt marsh, one of the best salt marshes in Maryland, and one of the best places to see salt marsh sparrow in Maryland. So I recommend you go there. So forgive me if I get a little bit scientific here. I can go through this fairly quickly, but we started off by coming up with this marsh condition model. We wanted a way of describing, of quantifying what's the quality of the high areas of marsh. And there's two factors we wanted to see. The elevation, because the higher the marsh is, the easier it's going to be to conserve long term. But then there's also this interior ponding thing. So we wanted a measure of like how intact was the marsh, how much vegetation is there. Well, luckily, a researcher called Neil Ganju in the US Geological Survey had already mapped out this ratio of unvegetated to vegetated areas for all the marshes around America's coasts. He calls it the UVBR, that's the metric. And what we did was we came up with a way of integrating these two measures to show the condition of the marsh. So these are the two factors. The maps you see, the SLAM map is the elevation, and the UVBR is the degree of ponding, with the better quality marsh being in the green. Yeah, no, the white. So when you integrate those, you get the map on the right, which shows the paler areas are the better quality areas of marsh. And you can see that the marshes along the shoreline tend to be higher and more intact. And it's the interior marshes that tend to collapse because they don't get tidal action from creeks and sediment deposited and such like. So there's an aerial image on the left and a model on the right, and you can see the rough correspondence, the darker areas of the wetter areas and the more collapsed areas. Okay, so from this, we produced a restoration decision model, and that used the same two factors with the idea that if your marsh is high, you don't need to add sediment, but if it's ponded, you would need to draw off that water with hydrological management, something like runoffs. However, if your marsh is low, you would need to add sediment. And so you can see here these stippled areas are areas in the interior where it's low and you would need to do a certain amount of sediment addition to bring that back to high marsh condition. Okay, so this is probably more information than I needed to put in there, but we wanted to prioritize areas for restoration. And so we used a marsh condition model, and we just used a few other layers, the vegetation type, because we wanted to target the grass marshes rather than the needlebush marshes, because salt marsh sparrow does not live in really extensive needlebush thickets. We wanted to look at areas also, slightly prioritize areas close to uplands, where marsh migration could occur, because some of the marsh can creep up slope with rising tides. And then thirdly, we wanted to prioritize areas where the state or the federal agencies had dredging operations where that could provide sediment for marsh building. And a few other layers like land ownership, large contiguous marsh blocks, and places where we knew salt marsh sparrows were abundant. So this is a lot of information that we have a technical report with all of this in it, so you can read in more detail. Now, what did we end up with products for this Marshes for Tomorrow plan? Well, we actually identified 29,000 acres in the end. We went above our target. And you can see the map on the left there is the priority marshes around Fishing Bay in Dorchester County. And you can see that a lot of those marshes, the ones that are outlined in black are our priority marsh areas for Dorchester County. And you can see that it's around the the shoreline fishing bay, which is particularly good marsh that we want to try to keep. And then along the Elliott Island Road down to the south to Elliott Island there, that kind of white area in the lower part of the picture. So these restoration decision model, which this is the map of, it gives us spatially explicit recommendations of what's needed where. We also then have estimated acreages that are needed for each restoration practice. And within these areas, we actually had a focus group to prioritize which project areas we should attack first. Now, this is great for landscape scale planning. I want to emphasize that when you think about a project on the ground, you need to actually go and take measurements on the ground and base your projects on that, not just on a model. So that's a really important part of that. Now, these models that we produced are actually publicly viewable on a website, which for Marshes for Tomorrow, the GIS Experience Builder. So if you Google that, you can actually peruse these models and just look at all the marshes on the lower eastern shore. Find your favorite salt marsh and see how it's doing. Okay. So this whole effort, we wanted to make it very collaborative. We had a whole load of agency staff, non-profit organization staff, public people. We had a series of meetings. We had a core analysis team of researchers and agency people that helped us to create and review these spatial models. We did technical workshops with agency staff. We had a community engagement team that hosted a series of public meetings across the Eastern Shore where people could come and look at the maps that we were producing. So here are agency staff looking at the maps, but we also had the public looking at the same maps to learn about how their marshes were doing. And then finally, we kind of prioritized these 29,000 acres. It was a wonderful process. We did that in 2024. And we had 32 partnering agencies, universities, and non-profits working with us. So a lot of different partners. So great. So having created this big report, which is now the report, actually I should emphasize, we have two reports. I'm going to show you one here. We produced a policy summary of our Marshes for Tomorrow report, which is online, but I have a few copies here of printed copies. So if anybody wants a printed copy, you can come and see me afterwards. And then we have a full technical report of 160 pages, some light bedtime reading, and that is also available online as well. So having done the plan, we want to go straight into implementation. And one thing we did was that because the money that the Fish and Wildlife Service gave us was not only for doing the plan, but was for actually doing projects on private lands in the Chesapeake Bay marshes. So our first one of those was on your land, right? The MOS Sanctuary at Irish Grove. We selected that a couple of years ago. We've been working very closely with Jeremy Castle and his Sanctuaries Committee, who've been great. And we designed a project on an area of marsh which needs attention in terms of getting water off the marsh. I'll show you some pictures of that later. So that was our first project. We are now approaching landowners in other parts of the Pocomoke Sound. We've approached, I think, 3 others so far, and we're going to be setting up projects on their land, probably hydrological projects as well, releasing trapped water. When we did these plans, we wanted to integrate the effort with a couple of other efforts. The state of Maryland was doing the wetland adaptation strategy, and then the Chesapeake Bay Trust was doing the wetland strategic plan. So our plan focused on the salt marsh sparrow and the high marsh has become like a kind of a module of those plans. And DNR in particular is working really closely with us now. And in a couple of weeks, we're going to announce a big grant that we've got from DNR with quite a lot of money for restoration. We're working with them on restoration of about 600 acres of marsh over the next 4 years. So that's really exciting. I shouldn't be telling you all details yet, so well, we'll probably do a press release in a week or two on that. So stay tuned. Okay, I think let's tell you a little bit more about the Irish Grove project, because that's the one that's furthest along. Basically, for those of you that have been there, you might recognize Rumbly Point Road, a public road running down through the middle of this marsh. Beautiful, this green marsh on each side is dominated by the Spartina grasses, which is the preferred habitat of salt marsh sparrow. Back in 2009, I walked the whole 2.5 kilometers from the forest edge to the tip, and I did a count of salt marsh sparrow.
Turn it down just a little bit.
So,
Just a little.
Turn it down.
okay, how's that? I counted 49 salt marsh sparrows along there, which is a pretty high number. I repeated that just 2 years ago and counted 25. So they've seemed to have declined, but they're still there. Still there in pretty good numbers. Now, you'll see a lot of ponds by the road. Some of those ponds are fairly old and well established, but what we noticed was a lot of them, see if I can point. A lot of them are actually very new. And so this here is an eroded area that opened up just a couple of years ago. It was vegetated and it started to lose its vegetation. Same thing with this area here. So we don't want these ponds to expand, because we could lose huge amounts of vegetation if we allow that water to stay trapped on the surface. So the conceptual plan here is to dig little runnels joining those waterlogged areas through the ponds to tidal creeks and allow the water to escape. We're not looking to bring full tidal action into them, because strong tidal flushing can flush out sediment. We don't want to lose the sediment from the marsh platform, but we want to get it just, it's like a sweet spot thing. We want to get enough, little bit of tidal action, but not too much, and allow that water to escape. So we did a design. This just shows the map. This is the lower eastern shore, and that's where Irish Grove is. So these are aerial images, and you can see where we have planned to dig little runnels. And these runnels are basically 12 inches deep, which is really not very deep at all, and anywhere from 12 inches up to 2 feet, although most of them we're going to try to make them narrow, so about 12 by 12 inches. And you will probably dig them by hand. That we may do some machine work. We're going to have to work with contractors on what works best. A sanctuaries committee is a bit nervous about putting machines on the marsh, but they have machines that have they're built in such a way that the pressure on the marsh, because of the caterpillar tracks, is actually less pounds per square inch than a human foot. So there is a case for actually having a machine doing it and having less impact on the marsh than loads of boots people wielding shovels. We'll have to evaluate this on a case-by-case basis. There are really wetter areas of the marsh and slightly less wet areas. So altogether, our treatment area is about 73 acres. The dimension, the length of the runnels that we've actually permitted is 5,300 feet, which is nearly a mile of runnels. It's going to take a lot of digging, but it just shows you that these runnels, they treat a very small area, so you need to dig a lot of them. It's a low impact method, basically. We have permits in hand from the US Army Corps and the Maryland Department of Environment. We still need to get a shoreline erosion permit from Somerset County. So we expect construction to begin in October this year. So the partners on this project, we have Fish and Wildlife Service. They're working with us as well as funding it. Dr. Alice Festerman at Towson University moved down here from New England about 3 years ago. She's an expert on the runaway method. Her postdoc work was in Marshes up in Massachusetts and Rhode Island. So she knows a lot about this method. And of course, MOS partner, and then Sustainable Science is a small kind of wetland engineering consultancy based in Denton, who measure water levels and such like. So here's one of the water monitors in one of those recently opened up areas of ponding that we would like to try to restore to a vegetated state. The monitoring that we're doing is obviously the levels of water, the vegetation extent, which we will measure by linear, the classic kind of quadrats along transects, but also from drone imagery and actually mapping out the extent of it in the project area. Breeding birds, and then nekton, if we can manage it, if we have the capacity to kind of count fish and stuff. Depends on the Fish and Wildlife Service, I think. So, and as I said, we're hoping to do our construction in 2026. So a little focus on birds here. We've been counting the birds there for the last 2 years, and we've been employing point counts, which are coupled with call playbacks, because many of the rails that live in the marsh are so secretive, you don't see them and you rarely hear them. You hear them mostly at night. So if you're doing your bird count, the best way to tally them is to actually solicit a response to a broadcast call. This goes to clapper rail, Virginia rail, also black rail, king rail. And this protocol is well established now. It's called the Salt Marsh Habitat and Avian Research Program, which is a bunch of universities in the Northeast that have been collaborating on salt marsh bird work for the last 15 years. We also have some autonomous recording units out there. We put them out in June and July just to see if there might be some black rails left. I mean, the answer is no, but one day we'll get a black rail maybe, because they become so rare. We are about to start doing a big research project in conjunction with the Runneling project, because Dr. Vesterman got an NSF grant. So we're going to study the impact of the Runneling construction on see how successful it is at bringing vegetation back, including bird habitat. Now this data map here basically is the map of records of abundance at each of our count points across the sanctuary for salt marsh sparrow. And you can see here's Romney Point Road that goes down here, but the farmhouse is right here, for those of you that have visited. So this is the marsh that you see as you go along the road. There's plenty of other marsh in areas that are more difficult to get to. Most of the salt marsh sparrows are actually quite close to the road, which shows you it's a good place to go to see them. So what we'll be doing is we'll be monitoring this each year for a while, and then seeing if our project areas here and then down here maybe get more salt marsh sparrows as a result of hopefully bringing back, revegetating some of those ponded areas. So I think that might be the end. I'll be happy to take any questions if you might have. Question here?
It's digging about 12.
Mind giving the mic?
Oh, yes, sorry.
So the runneling is a process of digging 12 inches down. How long does that runneling last before it needs to be redone?
That's a great question. Yeah. So the question, how long do these runnels last? And it's true that they do sometimes they can cave in from the edges and things like this, especially if the purple marsh crabs, which is a new invasive species in Maryland salt marshes, dig in their little burrows in the edges of them, which could happen. The answer is these runnels need fairly constant maintenance. And we visited some projects up in Rhode Island in the spring. A woman called Wendy Ferguson has been digging and managing runnels for 15 years now. And she basically says, yeah, you go in the marsh with a rake and a shovel and you do your gardening. And so we basically maintain these things. And one of our community kind of oriented approaches that we want to take is we would love to set up a marsh stewardship group. People, maybe MOS members, but also local people who love marshes, who want to go out there with rakes and shovels and actually maintain the runnels. So it's a really good point you make.
So what is the timeline for your milestone, meaning water level, vegetation coming back, birding, etc.?
Okay. So what's our timeline for success in a project? Well, that's a great question. The vegetation, that drawing off the water and starting to get a vegetative response can happen quite quickly with landing. You can have it within a year or two, which is very encouraging. As for a full recovery, it's going to take more time because some of these areas are quite extensive. But the great thing is that when you're playing with water levels in a marsh setting, you can actually have an impact fairly quickly. It's just that the vegetation takes a little while to respond, and then it takes a little more longer for the birds to respond to the vegetation. So, yeah.
So just a basic question about water and marshes. So I've always sensed that water and marshes are synonymous, they go together. But it's the flow of water that is critical and it is essentially the lifeblood of the marsh. When it's trapped, then it becomes deadly. Is that correct? Hence the need for draining.
That's exactly right. Yeah, basically the tidal flow of salt water is what makes the salt marsh, right? Just like the blood in your veins. And the fact is that excludes terrestrial plants because they can't handle the salt and they can't handle the flood. But it's when that water just sits there is when you get this decomposition of the soil in this ground surface collapse. So it's a little bit like if your heart stopped pumping, right, and the blood just sits there, you've got problems. So it's kind of analogous. In fact, our wetland engineer in sustainable science, he always, and at these permitting meetings, he talks about hydrology of marshes, and he has a slide of a heart on there. So there's actually, it's a good analogy. Yes.
There's three questions in the chat. The first one is, how long post-implementation do you expect to see a bird population increase?
So now we're getting to the real nitty-gritty. When are we going to see the birds increase? It's really hard to say. I would hope that within 5 to 7 years we might see an increase. If we see significant revegetation, we might be able to show an increase in 5 to 7 years. So it's tenuous. What we did, we like to peg our success metrics on the water and the vegetation because you can document those more easily. Salt marsh sparrows are not a particularly abundant species, so it might be a difference of you might have one nest in the project area before you do your bundling, and then you might have no nest the next year just by chance, and then the following year you might have 2. So because these densities are low and the project areas are small, it's very difficult to show a kind of statistically significant or meaningful change. But one thing we are hoping is that if we monitor birds at all of our project sites and we do more and more projects, and our partners do as well, then as a suite, we might show a significant increase. So,
Thank you. That kind of answered the second question. The third question was, can you explain the ARUs a little bit?
Autonomous.
yeah, I should have put the ARUs are autonomous recording units, and I should have put a photo of them because they're kind of snazzy. Basically, it's a box that you strap to a post, There's batteries in there. You turn it on, and you can program it to record all the sounds that it can detect at certain times. So you have there's lots of different programs. When we do the nocturnal program, right? It's the civil twilight and through the night, and we're trying to detect black whales calling because this really rare species. We want to know, could there be any of them at the project site? And so then it records all the sounds in a WAV, a WAV file, a sound file, and it used to be about 10 years ago that you had to sit there listening to all these recordings, trying to hear us. A black whale, it's like I can hear marsh whales, there's lots of those, but that's very intensive work. And so computer programs have now been developed that can identify bird calls, but you still need to verify them. In fact, a couple of years ago, the first time we put the AI user out there, we got something like 39 detections of black whale, all of which were false, right? So by listening to them, it's like, oh yeah, the computer program is not that good, it recognized this Virginia whale as a black whale. Then you can use those errors to further train the program. I don't know all the ins and outs of it. Our biologist, Bree Panos, does that. But yeah, the AI user kind of nifty. The first time I put them out in a marsh project, they weighed like 5 pounds each, big things, and I put them in a backpack and trudged through the marsh. And now they're just like little box that weigh about half a pound. So they've really shrunk in size. Technology has really improved quickly.
So I have 2 questions. First, I don't understand how the runnels work. Is it on a slight incline so that the water flows from the higher level to the lower level? And the second question is, why not use something like tiny, well, first of all, you could maybe line the runnels with plastic or recycled plastic or something so you don't have to keep going in there and dig it up. But the other question is, couldn't you use, I don't know the volume of water you're trying to get out of it, but couldn't you use like tiny windmills or solar powered pumps to push the water out through hoses? And I'm sure you've considered those things.
Actually, no, I haven't considered those. I haven't even thought about building a windmill in the marsh, but I'd love to get that one through NDE for a permit. But the question about how runnels work, it's just a gradient thing. It's only going to work if the waterlogged area you want to drain is higher than around the midpoint of the tidal range in the nearest tidal creek. And so you're connecting these two things with your runnel. And the higher the relative differences, the higher your kind of trapped water is relative to the tidal range in the creek, the more effectively it's going to drain. And so it's not an exact science. We're still kind of figuring out really how, it's more of an art. When we visited these projects in Rhode Island, it's very interesting how this person decided where to dig the runnels. She used the patterns of vegetation to find low points and things like this. So, but then when you ask, can we actually use kind of energy to pump water out? The answer is we probably could, but is it wise to rely on a kind of an artificial energy-driven solution, which probably wouldn't last long, probably be expensive, probably be difficult to maintain. What we're trying to do is to work with the natural hydrology of the marsh. Now, there are limits to that, because sea level rise is surging ahead, and who knows where we'll be in 100 years. But we want to try to work with the natural hydrology of the marsh for now, at least.
You mentioned engaging the local community during the process of identifying potential project areas. I'm curious what the general feedback buy-in enthusiasm was, especially amongst landowners who might have marsh on their parcels that might be their project areas?
Thanks, that's a great question. So, what kind of responses do we get from local people? Well, there's a lot of caveats to that, because when you put out a notice and invite people to come and talk about salt marshes with Audubon, guess what? You're going to get a biased subset of the population. So we got friendly faces, including landowners, and artists, and local people who had the time to come, and everyone loved it, right? But so like all 20 people that showed up loved it. Well, it's not exactly an unbiased cross section of the population, but our goal, I mean, you have to work with where you are. And what we really want to try to do is to build relationships with local communities slowly from a foundation, right? Start with people that love it. You do a project on someone's land and show it to be successful. And then you're talking to landowners about, hey, we're helping the marsh, which means we're improving your duck hunting, right? You're able to rent out your marsh for duck hunting for more money or for longer, and you're making a real difference. So we don't talk about climate change and things like that. We talk about how can we keep the marsh. When we get people talking about the marsh, and it's not like everyone showed up and they had really strong opinions about where they thought projects should be, but given a map and an opportunity to put observations on the map, things they've noticed, places they like to go, and things like that. It's about involving people and kind of building that engagement from a foundation. So when we get to creating a stewardship group, we'll probably have to start with undergraduate students from Salisbury University, right? People with energy and time and enthusiasm who maybe you can go and have a captive audience in a class. But once you've created a group, you can then attract one or two other individuals who live locally, and suddenly there's a kind of a place to go to do something that they maybe thought about but never had the opportunity to do. So it's kind of relationship building is a kind of a slow business, but it's important to realize that and just to kind of keep going with it and to be present. Now we're going to be hiring in the next couple of months a restoration project manager, and we want them to be based down on the Lower Eastern Shore, because they're going to have to go and oversee contractors and things like this. But having a presence down there is also going to help with that relationship work. I live in Baltimore, so that's pretty foreign to folks in Pittsfield, right? So we want to get more of a local presence. But it's a great question about that human dimension. Questions? Ah, yes, very good.
So, is the funding for this already set aside? Or, so it's not like, okay, we get started and then all of a sudden things change and now we have a half budget.
Right, so funding. Yeah. So if you ask a non-profit person about funding, they'll either bury themselves or talk forever. So I'll talk forever. We do quite all the funding for the moment. We have a couple of large grants. We have a couple of $1 million from Fish and Wildlife Service for these private land projects that we're setting up, including the MOS one. And then another large grant that I kind of alluded to from DNR, which is a 4-year grant. So we're going to have our plates full for 4 years. And then we have money from the NSF and a companion grant from the Allen Family Philanthropies to study the impacts of their running projects. So we're going to be busy for a while, but the big picture here is actually millions and millions of dollars to treat thousands and thousands of acres. I should have put the acreage on there from the report, but I think our estimate is we need something between 5,000 and 10,000 acres of hydrological work over the next 10 years, and that could cost about $26 million. So it's Audubon can't do it on our own. There are other groups like Ducks Unlimited, Fish and Wildlife Service, the Maryland Coastal Bays Program, and others who are also interested in doing this work. And we need a lot of organizations to do a lot of projects. And also it's ambitious. So it's not, we're not guaranteed to meet our target, but we have to try. So, and if we can, if we can get people excited about marshes, we increase chance that we might find public and also private funding of future projects.
Yeah, so if a private landowner had, I guess, kind of some marshland on their property, could they go ahead and do one of these rental projects on their own, or would they do budget permitting? And I guess kind of follow-up question is that I think it's $4,000 per acre. Is that taking into account all the permitting that needs to go into this?
Great question. So yeah, for a private landowner, they could, if they were really interested, they could hire an engineering company to do a design, and then they could apply for a permit, and then have the engineering company construct the design. Most private landowners don't kind of know the options that are out there. So there are very few private landowners that would know enough about the options to kind of go ahead and do that. And that it shows the value of the program that Fish and Wildlife Service has. It's called Partners for Fish and Wildlife, and that funds restoration work on private land only. And so that was the $2 million that we were given was from that program to work with private landowners. So we do the designs and submit the permits and everything kind of on behalf of the landowner. So, and the other part of your question was, oh yes, the permit process is baked into that cost. It's really difficult to come up with these cost estimates because basically that 4,000 acres includes permitting, design, construction, and some monitoring, but not all of the monitoring. We're making a real meal out of the monitoring for this big study. So we chose not to put that cost into the overall cost. So, yeah. Okay. I think that's it. Thank you very much, everyone.